We live under the illusion that the modern world is permanent. We flip a switch and the lights come on. We plug in our phones and they charge. We assume the electricity that powers our hospitals, our financial systems, and our entire civilization is a solid, unbreakable force. But the truth is much more terrifying. Welcome to another episode of History Glitch, where we examine the moments when humanity's operating systems catastrophically fail. Today, we are looking at the largest and most complex machine ever built by human beings, the North American power grid. Based on the fascinating book The Grid by Gretchen Bakke, we are going to explore the terrifying fragility of this massive interconnected network. We are going to look at August 14, 2003, the day a microscopic software error and a single overgrown tree branch combined to plunge 50 million people into darkness. To understand this glitch, you first have to understand a fundamental terrifying fact about alternating current electricity. It cannot be stored on a massive scale. The electricity powering the screen you are looking at right now was generated mere milliseconds ago at a power plant potentially hundreds of miles away. The grid is not a storage tank, it is a balancing act. The amount of power being generated must perfectly and instantly match the amount of power being consumed across the entire continent. If millions of people suddenly turn on their air conditioners, power plants must instantly spin faster. If the balance fails, the frequency drops, the physics break down, and the machine tears itself apart. In the summer of 2003, the grid was already showing its age. It was a patchwork of mid-20th century wires struggling to carry 21st century data and energy. On the afternoon of August 14th, the weather in Ohio was hot and muggy. Everyone had their air conditioning running at maximum capacity. The transmission lines high above the ground were carrying massive amounts of electrical current. As electricity flows through a metal wire, it encounters resistance, and resistance creates heat. The hotter the metal wire gets, the more it expands, and the more it expands, the more it sags toward the ground. In the control room of First Energy, a major power company in Ohio, the operators were monitoring this delicate balance. They relied on a sophisticated software system called the State Estimator to tell them if any lines were getting too hot or carrying too much load. If a line failed, an alarm would sound, allowing the operators to reroute the power and prevent a disaster. But at 2:14 p.m., a history glitch occurred silently inside the computer servers. Multiple alarm systems triggered at the exact same moment, causing a software race condition. The code essentially tripped over itself and froze. The alarm system crashed, but it did not tell the operators it had crashed. The screens still looked normal. The operators in the First Energy control room were now completely blind to the actual physical state of the grid. Out in the real world, the physical glitch was about to happen. A heavily loaded, high-voltage transmission line in Walton Hills, Ohio, was heating up and sagging lower and lower. It sagged so low that it touched the leaves of an untrimmed tree. The moment the high-voltage wire made contact with the grounded tree, a massive short circuit occurred. The electricity found a faster path to the ground. The circuit breakers did exactly what they were designed to do. They tripped and shut off the line to prevent a fire. Under normal circumstances, the operators would have heard the alarm, seen the tripped line, and rerouted the electricity. But because of the frozen software, they saw nothing and did nothing. This is where the unforgiving physics of the grid took over. When that first line shut down, the massive amount of electricity it was carrying did not just disappear. It instantly and automatically shifted to the neighboring transmission lines. Those neighboring lines were already running near maximum capacity. Now, forced to carry the extra burden, they began to overheat rapidly. They expanded, they sagged, and they too touched trees. They short-circuited and shut down. The electricity shifted again, overloading the next set of lines in a deadly domino effect. Within an hour, 3 major transmission lines had failed, and the first energy operators still did not know a catastrophic cascade had begun. By 4:05 p.m., the situation reached a critical tipping point. A massive surge of uncontrolled electricity began moving eastward toward New York and northward into Canada, searching for any available path. Power plants across the Northeast detected the massive voltage fluctuations. To protect their multi-million-dollar generators from being destroyed by the chaotic electrical surges, the power plant's automatic safety systems triggered. One by one, nuclear reactors and coal plants automatically disconnected themselves from the grid. This sudden massive loss of generation caused an even more violent swing in the grid's frequency. What happened next took only 9 seconds. In those 9 seconds, a tidal wave of electrical failures ripped across the northeastern United States and Ontario, Canada. Relays tripped, circuit breakers exploded, and power plants went dark in a cascading failure of unprecedented speed and scale. At 4:10 p.m., it was over. The largest machine in the world had broken. 50 million people across 8 U.S. states and a Canadian province were suddenly plunged into the mid-19th century. Traffic lights died, causing massive gridlock. Subways stopped dead in their tunnels, trapping hundreds of thousands of commuters underground in the sweltering heat. Cellular networks failed as their backup batteries drained. Water pumps stopped working, leaving millions without running water. In New York City, hundreds of thousands of people were forced to walk for hours across the bridges to get home, forming massive silent crowds moving through a city that had completely lost its voice. The 2003 blackout is the ultimate glitch because it proves that we do not fully control the systems we have built. We have constructed a technological civilization that relies on a machine so vast and complex that a single frozen computer process and one unpruned tree in Ohio can shut down the financial capital of the world. It is a terrifying reminder that the line between modern civilization and total darkness is just a sagging wire and a few lines of code.